Okay, so um, hopefully everything should work. Let me just. Okay, so now it should. Okay, so now it should work, but it's not, which is a bit confusing. Um, Moment, um, while I just fix this. Um, it doesn't seem to work. I'm not sure. Wait, let me. Yeah. Okay. Not sure why this is not working, but it. It's not too overly important, but yeah. Okay, so what we're going to do is we're going to go over the sample paper for math methods. Okay, and we're going to try and go through both in under 3 hours, hopefully. Let's start. Okay, question one. Random variable x is binomially distributed with 10 trials equal to 0.25. So p equals 0.25 at each attempt. The value of p is x. So the probability that x is greater than or equal to 1. Uh, Minus the probability that it's equal to 0. Yeah, that's the probability that x is less than 1, which is only 0. Then we get 1 minus how many was? We choose 0, and there's only one way to choose 0 things. Let's go to our formula sheet. The formula book is not loading. Okay, but either way, it's the probability of success, which is 1 over 4 of R, I believe. I believe it's R. Either way, we don't need the formula right now, because we know that, okay, we got the formula sheet anyway, so here it is. Yeah, so P to the power of R, in this case R is 1 minus P, so it becomes 3 over 4, n minus R, which is to the power of 10. So we get this. This cancels out, so it's just 1 minus 3 over 4 to the power of 10, which is the approximate area under the curve between x equals 1 and x equals 4 is found using triangles. I mean, rectangles. What is the approximate area? Okay, the first interval, so the corners the rectangles are determined by the y value on the right corner. Okay, rectangle, the height is just the y value at x equals 2. So y equals 2 multiplied by 2 squared, which is 8, is actually the area of the rectangle because the width is 1 for all the rectangles. Okay, so then what about 3? Okay, we sub in x equals 3. 2 times 3 squared. 3 squared is 9. 9 times 2 is 18. The last one is x equals 4. Okay, 2 times 4 squared. 4 squared is 16. Times 2 is 32. 32. 18 plus 32 is 50. 58. So it's A. Okay, if y equals cos squared 3x, then dy dx. Okay, we're applying the chain rule here. So the chain rule is the derivative of the inside, which is 3, multiplied by the derivative of whatever's here. In this case, we're applying the chain rule twice. So it's the derivative of cos 3x, which becomes negative sine 3x. Right, we just assume 3x is like one variable. And then now the derivative of goes out the front, and then we just leave whatever's inside normal. So then it's negative 6 sine 3x cosine 3x, which is A. Yep. From negative 2 to 0 of f of x is 4, and 0 to 3 is negative 10. Which of the following is true? Okay, so the bounds are the same, the area, because it goes from the integral from negative 2 to 3 is the same as adding the two separate integrals from negative 2 to 0 and then 0 to 3. There's 4 minus 10, which is negative 6. So it's B. The slope of the tangent to the graph of y equals ln of x squared at x equals e to e. Let's write it down. Find the gradient at x equals e squared. First derive this, so we're using the chain rule once again. So the derivative of x squared is 2x, and we times it by how we derive in the brackets. Okay, so we get that. We can cancel one of the x's out, leaving us with 2 over x. Yep, like so. And then we want the derivative at the x value e squared. So we sub that in. So it just becomes 2 over e squared. Which is B. Calculate 7. Okay, so I'm going to write that down. Okay, so here we have the integral negative 1 to 7 for the function 1 over square root of 2 plus x. What does this equal? Okay, well, let's use u substitution. U equals whatever's inside the square root. Du dx equals 1, so dx equals du. Yeah. Okay. We're going to change the bounds as well. Since we've subbed u in, we need to change these bounds because these bounds are in terms of x. Now we need to make them in terms of u. So we sub in the bounds. 2 plus 7 equals 9. So the upper bound is 9. The lower bound is 2 minus 1 is 1. So then it becomes 1 to 9 of 1 square root u du. Okay, it's not only square rooted, but it's also as a fraction. It's at the denominator, so we need to raise it to the power of -1/2. And then when we integrate, we add 1 to the power, and then we divide by that power. Up. And this is the same as multiplying by 2 at the front. Since we're dividing by half, same as multiplying by 2. Okay, u to the power, so we sub in 9 and then we sub in 1. So 9 to the power of a half is 3. And we subtract 1 to the power of negative, not negative, half, which is just 1. So the answer is 4 because it's 2 times 2. It's D. Yep. Going at a terrible pace, actually. The distribution of the student and each of the subjects is also known. Okay, so we're going to use that z-score formula. We need to use the z-scores to compare. You don't really need to do calculations for this. Let's think. The questions are just talking about involved. Okay. Let's think about it. The z-score, the thirds away from 2, right? Which is kind of how you calculate it. It's kind of like the calculation. So for science, it's this. Right, that's the overall formula. And then what we have is 15 divided by 70 minus 60. Or 70 minus 60 divided by 15, which is 2/3, because this goes to 10 and it's divided by 15. Common denominator of 5, so it cancels out. We're not comparing it with music. Okay. (72 minus 68 divided by 6). So the student scored 72 and the mean was 68. The difference in that is 4/6, which is 2/3. So science and math was the same. They performed equally well in maths and science, so it's A. Yep, the z-score was the same, and we can use z-scores to compare different. Given 5e to the power of 2x, rearrange the function to make x the subject. Right. 5e to this, well, okay. This part. We're going to divide by 5. We're going to apply the natural log. Then we're going to use our log laws, so we're going to put the coefficient, we're going to make the power the coefficient, so it becomes 2x. And then we're going to divide by 2 on both sides, giving us x. So it's ln of y over 5 divided by 2. That is not one of the solutions. They all involve square roots for some reason. Okay. We can use our other solution as a half for the log law. So in this case, it becomes the power, so we reverse it. So it's the same as applying a square root to the entire bracket. Okay, so x equals ln of square root of y over a. Nice, we're going good. An equilateral triangle has side lengths of 9 meters. The area of the triangle is what? We can, okay. Area equals a half BC sine of angle A. Yeah. In this case, it's an equilateral triangle, so B and C are both 9, And then sine of A, all the angles in an equilateral triangle are 60 degrees. Okay, so we have 81. We know that sine of 60 degrees is square root of 3 over 2. Now, the way my math teacher, Mr. Poyton, demonstrates this, or helps us memorize it, is easy as 1, 2, 3. Right? So it's, if you convert that to degrees, it's 30 degrees, 45 degrees, 60 degrees. Sine, cos, tan. Easy as 1, 2, 3. Square them, like square root of. And then for cos, it's just the reverse. So reverse and. Yeah, but we're only looking for sine here. Sine of pi over 3, otherwise known as 60 degrees, is square root of 3 over 2. And we know that it was already being divided by 2. So the denominator becomes 4. So it's actually C. Okay. If the sample size is decreased, but the sample proportion and the confidence levels remain the same, the width of the confidence interval. And we need to recognize that the width is our margin of error, which is represented as E. Z square root 1 minus P over N. So the population proportion is P hat. Okay. So the question is increased, but everything else stays the same. Changes Z. Sample proportion changes P, but since they are maintained and we only decrease sample size, what happens? Decrease this number, you're actually going to increase the width. You're going to increase the margin of error, because when you divide a number by a small number, it's going to be relatively greater than if you were to divide it with a very large number, right? So decreasing sample size would increase the width. So, yeah. Okay. Now we can get straight to correspondence. So now what I'm going to do is I'm not going to really demonstrate exam insights. I'm not going to change the or whatever. So here we go. We're deriving this. Okay, chain rule. We get the derivative of the brackets. Okay, so what I'm going to do, I'm actually going to put this. That makes it a bit better. I'm not sure though. Okay, so the derivative of this is 5. So we put 5 out the front, but also there's a constant of 3 out the front. So 3 times 5. Then we derive ln of 5x, which is just 1 over 5x, right? 1 over what's in the brackets. 5 cancels, leaving us with 3 over x. Okay. Two functions multiplied together, we're using the product rule here. So u is x cubed, and then we're going to let v equal cosine of x to the power 4 plus 1. Okay, so we know equals u prime v plus u v prime, or something like that. You can rearrange the terms. It's commutative. Okay, so now u prime in this case becomes 3x, and then you subtract 1 from the power. V is just cosine of x to the power 4 plus 1. We don't change that. U is just x cubed. When we derive this, cosine goes to negative sine. So I'll put in brackets negative sine x to the power 4 plus 1. However, we need to note that we need to multiply by the derivative of the inside. We're applying the chain rule. So the plus 1 does not become anything. It doesn't contribute to the derivative because it's a constant. It doesn't affect the rate of change. However, x to the power 4, okay. You do not need to simplify. Based on that, I'm assuming that this is a valid answer, just leaving it in this format. So we'll keep proceeding. Okay, C. The integral of 3e to the power 4x. When we're integrating, we're doing the reverse. Okay, when we're dealing with exponential functions, they're very easy to integrate. So we have the constant. We don't do anything to the constant. So it's just 3. And we're multiplying with e to the integrate, or we derive e to the power of x. We get back e to the power of x. That's a special characteristic of it. However, we're applying the chain rule. Right? 4x is the power by the derivative because we're integrating. If we were deriving, then we would just multiply by the power. But here we're dividing by the power. And then since it's an indefinite integral, we just add plus c. So we get 3 over 4 e to the power 4x plus c. Starsky says, methods, my beloved, one of the only subjects I'm actually confident in. Yeah, that's, I think a lot of people think that. And also it's the one that we care for since it's one of the last exams. So that's pretty good. Okay. So I believe that's it. Yeah. See the marking guide. Correctly states derivative. It's just 3 of x. Yep, we get a mark for that. Using the product. Okay, so they did it in the opposite direction that I did. Okay, so direction that I did. Okay, so this becomes negative x cubed sine, yeah, multiplied by 4x cubed. Yep. Okay. Provides a statement identifying the use of the product rule. This is, I'll give myself a tick. First term, this is, and then second term, yep. So here it is. So in this case, this was the sample response, while this was the second term. The sample response, while this was the second term. But yeah, this is overall correct. Okay, so 3 over 4 e to the power of 4x plus 6. Any exam, to be honest. Yeah. Okay. Question 12. Okay, 3 marks. Should be very, very simple, very easy. Okay. I'll try and move this like light so that it's actually okay, this light should hopefully. Here we have a simple log question. So the bases are the same, but there's a coefficient here, so we need to account for that. So the coefficient goes as a power, so log base 6 of 2 squared, which is 4, and then we apply our other log law, which is when we add logs, we multiply what's inside the brackets. This is 6 squared, right? So then the square can go out the front. Since the base and what's inside the bracket equal, it's just 1, so it's 2. So it's 2 times. We have to see if we have any energy left to actually do well on the exam. Yeah, that's true. That is actually very true. But given that, actually no, it depends on what subjects everyone's doing. Okay, so this we can actually use our change of base rule. This I think links to it. So we can see that log base a of x equals log base b, which is some arbitrary base that you can just make, base b of a. Okay. So the one in the brackets in the denominator becomes the base. That's something to be wary of. So this becomes the base. So 64, log base 64, it equals log base 64 of 16. Okay. Let's get it in prime, down to its prime factors. Instead, express this in some way as 64 to the power of something. Cube root of 64 is what? It's 4. And then so 2 over 3. 64 to the power of 2 over 3 equals 16. Which means it's 2 over 3. Because like I said before, the base and then whatever's inside the brackets equal, so it becomes 1. Okay. So now let's check the marking scheme. Okay, we got 2 for question 12 part A. We got 2 over 3. And